All right, so we're gonna look at doing a multiple mass problem here. So we need to go over to our green sheet and look at those steps we need to follow whenever we can identify a multiple mass problem. Multiple mass problems can be identified because I have multiple masses, yes. And so what we have to do is the first thing is identify the direction of acceleration as positive for each object. So looking at my situation here, this one is going to accelerate to the right. This one is going to accelerate down. Okay. Now, how I know it's going to actually accelerate is if I think about this force of friction, 0.2 times 2 kilograms times 9.8, the force of friction is going to be much less than the force of gravity over here. So it will start accelerating, will start moving. So we will be using that kinetic friction. The next step I need to do is draw some free body diagrams, generate some equations, and then I need to link those two sets of equations, one of them for M1, the other set of equations for M2. I need to link them because they're going to have a common acceleration. And so since this acceleration to the right would be positive and this acceleration would be negative, I can't say those two accelerations are equal unless I make those two accelerations both positive. And so that's why we do that first step, is so when we go to link them down here, those two accelerations link up. We're also going to have a third law pair. That's a force that connects the two objects. So let's draw our free body diagram and kind of identify those forces. So on our 2 kilogram one, I have my M1G. I also have a normal force perpendicular to the surface. There is a little bit of friction acting on it here, and there's tension pulling it forward. Now on M2 down here, I have M2G, and I also have tension. Now this tension, this is the string that connects them. This right here, these two tensions, this is your third law pair. These are the two forces that connect our multiple mass situation. So I need to know that these two tensions are the same and these two accelerations are the same. Namely, I need these two tensions magnitudes to be the same and directions to be opposite. So let's go ahead, generate our equations, see how that looks, and then we will go from there. So for M1, I'm going to have two equations, one in the y direction, so the sum of the forces in the y direction is going to be 0. This one is not accelerating. And for the x direction, the sum of the forces in the x direction is going to cause M1 to accelerate. Now, something that's going to be a little extra for us here, when we have multiple masses, we need to identify which mass is accelerating for that given equation. We just can't write MA. We have to say, is it M1A or is it M2A that this equation goes with? In my y direction, I have normal force minus M1G equals 0. In my x direction, I have to the right is positive, so I have tension minus force of friction equals M1A. Now for M2, my other mass, there is no x direction forces, there's only a y direction force. Now a little different here is I've identified down as my positive direction. So down being positive means that when I sum up those forces in the y direction, set it equal to M2A, down is positive. So this is M2G minus tension equals M2A. And so this is where we get a chance to check, make sure we're doing things right. And so because this is a third law pair, those two forces should be equal and opposite. So T and T are the same thing. So as long as I have a T in both of them, we're good. And then opposite, so one of my T's should be positive and one of my T's should be negative. We're on track. Let's keep going. So next, we are going to have to solve. So now I have essentially two equations with two unknowns, tension and acceleration. So what I'm going to need to do, I have this friction here. I'll have to substitute here. And then I'll have to maybe solve for tension, substitute in, solve for acceleration. So let's go ahead and do that. So for friction, we're going to start our substitution process. So force of friction is mu times the normal force equals M1A. Normal force, I'm going to go ahead and solve for the normal force in the y direction here. Substitute that in. So now I have tension minus mu M1G equals M1A. Solve for tension so I can substitute that all in. We have two unknowns, so we're solving our system of equations here. So I have tension is M1A plus mu M1G. And now I'm going to take all of that and I'm going to substitute it in for tension. And once I do that, I won't have tension in this equation. I'll just have acceleration, so I can solve for acceleration, plug that acceleration back in and over here, and find tension. So here we go. So m2g minus, and I got to open up a parentheses. This is where some people make some mistakes on this one. I have m1a plus mu m1g equals m2a. Go ahead, move my m1a over to the other side, and I'm going to make a mistake here, and I want to see if you can catch it. So I'm going to add it over to the other side. What mistake did I make here? Yes, that negative sign. With that parentheses, I need to distribute it to both of those terms. So this should actually be a minus sign. Yeah, make sure you distribute that negative sign when you substitute in for tension and there's a negative in front of it. All right, so now I just need to factor out an a. So here I have m2 plus m1 times a. So I should always have another check for myself here, is that those two masses are added together at the end. So divide that over, so now I have m2g minus mu m1g all divided by m1 plus m2 equals a. All I need to do now is plug in my numbers. I know my two masses, I know my coefficient of friction, so let's go ahead and do that. So I have 4 times 9.8 minus 0.2 times 2 times 9.8, all divided by 4 plus 2 will give me an acceleration here of 5.88 meters per second squared. I can then take that acceleration, plug it in here along with those numbers, and if you do that, you will get what? We have 2 times 5.88 plus 0.2 times 2 times 9.8. We get a tension of 15.68 newtons. There you have it.